Alright, I'm going to record some examples of some of those problems that you missed on the distance, rate, and time problems. One of them said 2 jets leave an airbase at the same time and travel in opposite directions. One jet travels 84 miles an hour faster than the other. If the 2 jets are 4,296 miles apart after 3 hours, what is the rate of each jet? So first of all, we have to know the formula. And the formula is that rate times time equals distance. So rate times time equals distance. On these problems, you want to show the rate and the time for each part of your trip, I'll call it. But in this case, we have 2 jets that left at the same time and traveled in opposite directions. So one went that way, one went this way. What we want to do is show the rate times the time for both of them. On this one, it has information about the rates. One jet travels 84 miles an hour faster than the other. So on one of them, we're going to leave our rate as just R. On the other one, we have to change it because it didn't go the same rate, it went faster. So instead of using R, we are going to use R plus 84 because it went faster. The 2 jets are 4,296 miles apart after 3 hours. So that means for both of them, the time's 3 hours. So here my time's going to be 3 hours. Here my time is also going to be 3 hours. So what I have is R times 3, which would be 3R, plus R plus 84 times 3, which if I use my distributive property would be 3R plus, I got to take 84 times 3, so that would give me 12, carry my 1, 24 plus 1 would be 25, so 252 equals my 4,296 miles apart. So once I have my equation set up, I can go ahead and just solve that. 3R plus 3R would give me 6R plus 252 equals my 4,296. I have to subtract my 252 to move it to the other side. So 6R is going to equal 4,044. And I'm going to grab my calculator here. I'm going to divide my 4,044 by 6, and so R equals 674. Now, this is the rate of one of my jets. That's the first one. The rate of the other one is the R plus 84, so I would have to do R plus 84, 674 plus 84 then. Is 758. So the question wants to know what is the rate of the faster jet and what is the rate of the slower jet. So the 758 would be my faster jet, and my slower one would be the 674. So I had my rate, and then I had my rate of my other one, which was R plus 84 because it went faster. Another problem that's really similar to that last one that I just did that you missed. 2 buses leave towns 1,484 kilometers apart at the same time and travel toward each other. One bus travels 8 kilometers per hour faster than the other. If they meet in 7 hours, what is the rate of each bus? So if I go over here to my scratch paper again, this time my 2 things are traveling towards each other. So one bus is going this way, one bus is going this way. Again, we want rate times time for both of them. And again on this one, we know that one of them is going 8 kilometers per hour faster than the other. So on one of them, we're just going to leave it as R. On the other one, we're going to change it. Since it's going faster, we have to do R plus 8. So R plus 8 would be my rate. They are 1,484 kilometers apart after 7 hours. So again, substituting in for my time, I'm going to have 7 hours for both of those times. And so here, R times 7 would be 7R. Here, R plus 8 times 7 would give me 7R plus 56 to equal my 1,484. So 7R plus 7R would give me 14R plus 56 equals 1,484. And so here I'm going to have to subtract my 56 to move that to the other side. 1484 minus 56 is 1428. So 14R would equal 1428. I'm going to divide by 14. And so R is 102. So again, the R is the rate of this first side. This one went 102. The other one was R plus 8. So 102 plus 8 would be 110. The question then has the faster one and the slower one again. So the faster one is my 110. My slower one is the 102 for my two answers. All right, this next one is just slightly different than what we did. It says two cyclists start at the same point and travel in opposite directions. One cyclist travels 5 miles an hour slower than the other. If the two cyclists are 78 miles apart after 2 hours, what is the rate of each cyclist? So again, if we go over here, we want to show each of those. The cyclists are going in opposite direction. We want the rate times the time for each part of that. Right now I have my rates as being the same, but we know one cyclist is 5 miles an hour slower than the other, so we're going to replace this one with R minus 5. Since it went slower, we have to subtract this time. Two cyclists are 78 miles apart after 2 hours, so my time here is 2 hours, my time here is 2 hours, and so R times 2, which would be 2R, plus R minus 5 times 2, which would give me 2R minus 10, equals my 78 miles that they were apart. 2R plus 2R would be 4R minus 10, then equals 78. I'm going to add my 10. This time I've got to add to move that over. So 4R equals 88. And when I divide by 4, R is going to equal 22. That again is the rate of the first one. That one went 22. To find the rate of the second one, I know its overall rate was R minus 5. So 22 minus 5 would give me 17. This time it asks for the slow one first, which is the 17, and the faster one second, which is my 22. So very similar to that one, the other two we just did, only this time I went slower, so I had to subtract instead of add when I did my overall rate for that second one. The other distance, rate, and time problems are having to do when you're going with the wind or against the wind, with the sidewalk, against the sidewalk, up a stream and down a stream, those kind of things where we have an overall rate going in each direction. So what I need to know here when I'm solving these ones, if I can find my paper here, is that when I'm going with something, I'm going to add my two rates. So in this case, I am going a plane and a wind, the plane plus the wind. If I'm going against, the wind is going to slow me down, so I'm doing the plane minus the wind. So those would be my rates. So I need to know again that rate times time equals distance. And so I'm going to set up equations for each part of this, and it says an airplane travels 6,381 kilometers against the wind in 9 hours and 7,191 kilometers with the wind in the same amount of time. What is the rate of the plane in still air, and what is the rate of the wind? So the first part, the distance was 6,000, I'm going to write it down here, 6,381 miles. I'm going against the wind, so against the wind was BP minus W, and my time is 9 hours, and so I'm going to have times 9 there. The other part of that, we went 7,191 kilometers. This time we were going with the wind, so plane plus the wind, in the same amount of time, so the same amount of time is still the 9 hours. So what they're going to do when they have these problems is they're going to go ahead and divide each of the equations by whatever the time was. In this case, the time happened to be the same, so the 9 hours. So we're going to divide by 9 here and divide by 9 here. And so what happens is here we're going to get P minus W equals something. Here we're going to get P plus W equals something. My 9 hours cancel out. So if I divide 6,381 divided by 9 is 709, and 7,191 divided by 9 is 799. So now we have a system of equations where we have the P minus W and the P plus W. What we can do is add these together, because when you take the negative W and the positive W, they're going to cancel each other out. So a P plus another P would be 2P. The W's cancel, and I'm going to add my 709 plus my 799, which is 1508. So all we need to do in order to solve that is divide by the 2. If I divide by 2, the plane is going 754. So one of the questions is, what is the rate of the plane? The plane is going 754. Now I also want to find the rate of the wind. In order to find the rate of the wind, you can use either of these two equations over here where we've already divided by 9. The easier one is to use the one with the plus sign. So the plane speed plus the wind speed was 799. Right there. I knew the plane was 754, so 754 plus W equals 799. So all we have to do to solve that is just to subtract 799 minus 754. And we get 45. So our wind was 45, our plane was 754. So one more distance, rate, and time one where we're going upstream and downstream. It says a motorboat travels 324 kilometers in 6 hours going upstream and 276 kilometers in 3 hours going downstream. What is the rate of the boat in still water, and what is the rate of the current? So again, on this one, we've got the boat and the current, and we've got two different rates. When we go upstream, it's going to slow us down, so we would have the boat speed minus the current. When we're going downstream, the stream is going to make us go faster, so we're going to have the boat plus the current. Those are going to be our rates. And so a motorboat travels 324 kilometers. 324 is the distance. In 6 hours going upstream. So upstream I'm going slower. I'm going to take the boat minus the current times my time, 6 hours. And it goes 276 kilometers. So 276 kilometers in 3 hours going downstream. So this time my time is 3 hours. If I'm going downstream, I'm going faster. So I'm doing the boat plus the current for my overall rate. Again, they're going to go ahead and divide by the times right away. So I'm going to divide by the 6 on the top equation, 3 on the bottom equation. So that here I'm going to get B minus C equals something. On the second one, I'm going to get B plus C equals something. And so I'm going to go ahead and do my division. 324 divided by 6 is 54. 276 divided by 3 is 92. So again, I'm going to use these two equations. Notice the C's are opposite, so when I add those together, they'll cancel out. B plus another B will be 2B. C's cancel. We're going to add the 54 and the 92. 54 plus 92 is 146. Going to go ahead and divide by 2, so B is going to equal 73. I know my boat's speed. I also need to find my current speed. So in order to find the current speed, again, I'm going to look for that one where I'm just adding the two values together. I know my boat plus my current was 92. If my boat is 73, 73 plus my current is 92. All I have to do is subtract my 73. So that means my current is 92 minus 73, which is 19. And there I get my answer. So slide that over here. 92 minus 73 gave me my answer of 19 for my current. So two different ways you're going to see these problems, where you're going with the wind, against the wind, with the current, against the current. You do them one way. Otherwise, you have the ones where you are going in two opposite directions, or maybe you're going toward each other, and you want to represent those with the rate times the time for each part of your trip, and then edit it as much as you need to in order to solve the problems.